Hey guys, welcome back to my channel. So today we are going to discuss another interesting topic of electronic subject, which is PN junction. So let's get started. There are three biasing conditions for PN junction diode. First one is there is no external voltage provided to the PN junction diode while it is at zero bias. Second one is forward bias. The p-type is linked to the positive terminal of the battery while n-type is linked to the negative terminal of the battery. Third one is reverse bias. The p-type is linked to the negative terminal of the battery while n-type is linked to the positive terminal of the battery. So let's discuss first one, PN junction diode under zero bias condition. Zero bias is the condition of thermal equilibrium where the number of charge carrier on both the ends is balanced. As there is no external power supply to the diode is applied, the electron diffuse toward p side and the diffusion of hole is toward the n side, resulting in the generation of electric field because of these charge carrier of diffusion. So, as you already know, the PN junction diode circuit diagram, this is the p-type region and this is the n-type region. And in p-type, holes are majority carrier and n-type electrons are majority carrier. And this is the electric field generated across the PN junction, and the region which is connected to PN n-type is called PN junction, and this region is called depletion region. So what happened in zero bias condition is the movement of holes or electron occurs at zero bias condition or state as no potential is external applied at external, which prevent the passage of electric current to flow in the diode. As you can see that the n-type region and the p-type region are connected toward together and are grounded as there is no external supply voltage is provided. So under this condition, how it will work, as the diode is not connected to uh, supply voltage, so no current will flow in the diode. This generated electric field generated by both the carrier tends to oppose each other. As the electron in the n region and holes in the p region are majority carrier, they maintain the condition as they no current flow in the circuit. And if the depletion region layer is not wide enough, then this means that this situation is under zero condition. For further, there is no movement of the charge carrier in the depletion region, as you can see here. In this way, the diode is work under zero bias in order to attain the state of thermal equilibrium. So, the next is PN junction with forward bias condition. The PN junction is said to be forward biased when the P type is connected to the positive terminal of the battery and the N side is connected to the negative terminal of the battery. The built-in electric field at the PN junction and the applied electric field are in opposing direction when the PN junction is forward biased. As you can see that here the negative terminal of the battery is applied to the N region and the positive terminal of the battery is applied to the P region, and the developed electric field direction is this, as you can see, and the direction of the applied voltage is this. So these are both are opposite in direction. If this external voltage becomes greater than the value of potential barrier, as you can know 0.7 for silicon diode and 0.3 for germanium diode, the potential barrier opposition will be overcome and current will start to flow. This is because the negative voltage pushes or repels electron toward the junction, giving them the energy to cross over and combine with the holes being pushed in the opposite direction toward the junction by the positive volt. voltage. This results in a characteristic curve of a zero current flowing up to this voltage point called the knee on the statics curves, and then a high current flow through the diode with the little increase in the external voltage as shown below. So this is the voltage curve for the forward biasing condition, and this is the forward current and forward voltage. And the what is IF? As you can know, when the holes travel from the P region to the N region, the current flowing through is called forward current, and when the electrons flow from N region to the P region, the current flow from this in this condition is called reverse current. The application of forward biasing voltage on the junction diode results in the depletion layer becoming very thin and narrow, which represent a low impedance path through the junction, thereby allowing a high current to flow the diode by a small increase in bias voltage. As you can see here, the depletion region becomes very thin as the negative voltage applied at the N region pushes or repel the electron to recombine with the holes, and the positive voltage at the P region uh, pushes and repel the hole to recombine with the electron. As the depletion region becomes very thin and very narrow, and allowing the current to pass through a diode is a very high current. Since the diode can conduct infinite current above this knee point, as it effectively becomes a short circuit. Therefore, resistors are used in series with the diode to limit its current flow. As you can see, the diode is short circuit becomes short. So in for this case, the series resistors are used in this circuit. Exceeding its maximum forward current specification causes the device to dissipate more power in the form of heat than it was designed for, resulting in a very quick failure of the device. So the next is reverse bias PN junction diode. So this is the circuit diagram for the reverse bias PN junction diode. When diode is connected in reverse bias condition, a positive voltage is applied to the N-type material and a negative voltage is applied to the P-type material. As you can see here is that the positive voltage applied to the N-type material attract electron toward the positive electrode, positive electrode and away from the junction. When we are giving the positive supply to the N-type material, the electrons are attracted toward the positive electrode, while the holes in the p-type and are also attractive away from the junction toward the negative electrode. And similarly, when the negative supply is given to the p-type region, the holes are attractive toward the negative electrode and away from the region. The net result is that the depletion layer grows wider due to lack of electron and holes and present a high impedance path, almost an insulator, and a high potential barrier is created across the junction. As you can see here is that the depletion layer become wider due to the electron and holes away from the PN junction. Barrier is created across the junction, thus preventing current flowing from through the semiconductor material. This condition represents a high resistance value to the PN junction. Practically zero current flows through the junction. However, very small reverse leakage current does flow through the junction. One final point: if the reverse bias voltage VR is applied to the diode is increased to sufficiently high enough value, it will cause the diode's PN junction to overheat and fail due to the avalanche effect around the junction. This may cause the diode to become shorted, result in the flow of maximum circuit current, and this shown as a step downward slope in the reverse static characteristic curve below. As you can see here, this is the reverse characteristic slope curve, and this is the reverse breakdown region, and this is the circuit diagram, or you can say the connection diagram we used for reverse bias region. And we are in this here, the polarity of diode has changed and the resistor in series are used. Sometimes this avalanche effect has practical applications in voltage stabilizing circuits where a series limiting resistor is used with the diode to limit this reverse breakdown current to a preset maximum value. As you can see here, the series resistor is used in the in series with the diode to limit the high resistance current, thereby producing a fixed voltage output across the diode. These types of diodes are called as Zener diode, which we will discuss later in the video. So guys, if you like my video, please do subscribe to my channel and press the bell icon for the latest update. And you can comment me as what topic do you want me to discuss in next video. See you in the next video. Bye.